Welcome to Quest Edu Physics students. In this class, we are discussing about the prism material and as well as what is the prism is and how can we find out the refractive index of the material of the prism students. Most of you maybe watched a prism and you know that how it looks. Generally, in laboratory, we use the equilateral prisms. Okay, and we have the right angle prisms and as well as the thin prisms too. But today we are talking about the equilateral prism. And you know that if you observe the board here, you will find that it is the equilateral triangle and learn that all the angles are same. And what is a prism is? Prism is a transparent substance which is bound between two refracting surfaces. Prism is a transparent substance which is bound between two refracting surfaces, students. If you watch this diagram, you will find three refracting surfaces here. Actually, this is the base of the prism. Though it is a refracting, we are considering it as the base of the prism, and it is the first refracting surface and it is the second refracting surface, students. Here, if you go with elliptic geometry, name it as A, it is the B and it is the C. Okay, here A is the angle of prism and here BC is the base of prism. Here in this class, we will derive an expression for the refractive index of the material of the prism by using simple geometrical formula, students. Before that, you have to know what is the refraction is. The answer is very simple and clear. When light passes from one medium to another medium, it changes its path. Obviously, it happens. If you go strictly, you can define the refraction like this, students. Is the change in the speed of the light when it is traveling from one medium to another. Is the change in the speed of the light when it is traveling from one medium to another medium. And what is the refractive index? It is the relative term, students. Okay, students, it is the ratio of the speed of the light in one medium with respect to the second. Is the refractive index is the ratio of the speed of the light in one medium with respect to the another medium. Okay, generally, the medium in which the prism is kept is said as the first medium and the material which is the second medium. Here it is a glass prism. Okay, this glass material has a refractive index. That refractive index is shown with the letter mu. We are calling it as the second medium and it is the first medium. The first medium is the medium in which the prism is kept. Okay, students. To derive that expression, we have to do a little geometry, students. First, we have to drop a normal over any refracting surface, students. Here, we are using the sign convention. Okay. Just we have to make the light rays to fall from left to right. To make so, I dropped a normal over the AB. AB is the first refracting surface. And it is normal, which is drawn. We are naming it as N. Normal means what? It is making an angle of 90 degree with this refracting surface. Okay, students. Then after, we are making a light ray to fall on the prism, making certain angle. It is the actual path of the light ray, what I am showing. Okay. Actually, light would pass in this direction, students. This prism material, this prism intercepted the path of the light ray. That's why it undergoes some deviation, students. And we learn that when the light is passing from rarer to denser medium, it bends towards the normal. While learning about the laws of refraction, we learned when light is passing from rarer to denser, it bends towards the normal. Same thing will happen here. Let's say it is the incident ray. I'm naming it as P, and the point of incidence it is Q. Okay, actually it has to pass in this way. Because of the different refractive indices, strictly densities of the medium, it changes its path and it travels like this. It get deviated at this point, students. It got the deviation, and here it moves straightly. And you have learned that refraction take place at the boundary of the two different media. I mean, refraction doesn't happen in a single medium. That's why it doesn't undergo any deviation here. After reaching the surface, it has to enter into the second medium, that is air, students. There I am dropping a normal. Again, this normal being dropped here. Okay, students, a normal is drawn. Call it as N dash. Here it is P, it is the Q, and it is R. Then what could happen? It is traveling from denser to rarer medium. Here it traveled from rarer to denser medium at first refracting surface. At the second refracting surface, it is passing from denser to rarer. Okay, students, when it is traveling from denser to rarer, obviously it bends towards the normal. There's a normal here. Okay, here to away from the normal. It is moving away from the normal. Here, it passes in this way. Okay, if you produce it back. Okay, students, here it is P, it is the Q, it is R, and it is the S. Okay, students, again we got two triangles here and as well as a equivalent, what's that? Parallelogram, students. Here it is Q, I'm calling it as X, and it is the Y. And if we watch it carefully, students, actually the light has to pass in this way. Okay, light has the rectilinear propagation, you know that. It has to pass in this way, but it changes its path. This thing is known as the deviation, students. We are showing it as angle T. Actually, it undergo two deviations at two refracting surfaces, students. Here for once, here for once. See this? Add this, AQX. It undergo a deviations here. In the same way, ARX, it again undergo a deviation. Here I am saying it is the angle of incidence. I'm calling it as I1. Here it came out from the second surface. Here the angle of emergence it is. I'm calling it as I2. And see, at the first refracting surface, it deviates, and I'm calling it as the angle of refraction at the first refracting surface is R1, and here it is R2. Okay, students, if you watch it, here this angle might be equal to I1 minus R1, internal opposite angle, students. Here it is I2 minus R2. I hope you understood. This part is I2 and is R2, and it is the I2 minus R2. Here it is R1, it is I1. This angle is equal to I1 minus R1. Okay, this is the path observed by the light ray when it passes from rarer to denser, denser to rarer again. Okay, students. Here all these things happen in that way when light propagates from one medium to another medium. If you watch this triangle carefully, it is the front part of the prism, students. Okay, it is the equilateral triangle, and PQ is the incident ray, QR is the refracted ray, RS is the emergent ray. And we have a parallelogram here, that is AQ XR. Similarly, we have the two triangles here, QXR and as well as the QYR. Here, see this. In parallelogram, I am taking the parallelogram. Okay, AQ XOR. Okay, students. See this, AQX, it is a right angle. AQX is equal to right angle, and we have one more right angle here. ARX, angle AQX plus angle ARX. This is ARX plus angle A plus angle QXR. See this, it is QXR. This angle QXR is equal to 360 degree. We know this. Okay, students, here I said angle AQX is equal to angle ARX is equal to 90 degree. These are right angles. Then it could be rewritten as 90 degree plus 90 degree plus angle A plus QXR is equal to 360. Okay, students, and angle A plus angle QXR is equal to 180 degree. Okay, here 90 plus 90, 360 minus 180 is equal to 180 degree, students. Let's take it as the equation 1. And further, we are taking the triangle QXR. We had to find out the angle QXR, students. And we have learned that in a triangle, the sum of the angles is equal to 180 degree. Here also, R1 plus R2 plus QXR is equal to 180. I am writing the same. In triangle, this triangle it is, students, it is QXR. R1 plus R2 plus QXR is equal to 180. Okay, students. Okay, say it as a 2. On equating these two, we will get R1 plus R2, okay, plus QXR is equal to angle A plus angle QXR. Here these two angles get cancelled and we get R1 plus R2 is equal to angle A. Freeze this one, students. Okay, we had the relation between the angles of refraction and as well as the angle of prism as R1 plus R2. The sum of the refractions is equal to angle of prism. In the same way, we are taking the triangle QYR, students. From triangle QYR, okay, we are finding the angle of deviation by using this triangle, students. And you have learned that in a triangle, the sum of the interior opposite angles must be equal to exterior angle. Here exterior angle is angle D, interior opposite angles are I1 minus R1 and I2 minus R2. I am using the same, students. That is I1 minus R1 plus I2 minus R2 is equal to angle D, or you can write I1 plus I2 minus R1 plus R2 is equal to angle D. Okay, students, but we have angle A is equal to R1 plus R2. I am writing this value here and I will get I1 plus I2 minus A is equal to angle D, and I1 plus I2 is equal to A plus D, angle A and angle D. Okay, freeze them. We have the two relations here, students. That is, the sum of the refractions at two refracting surfaces is equal to angle of the prism, and the sum of the angle of incidence and angle of emergence are equal to the sum of the angles, what, angle A and as well as angle D. Okay, students, by using these two, Okay, we derive an expression for the what's the refractive index of the material of the prism or coefficient of refraction of the prism. Here, if you recall back your memories, you will find that according to the Snell's law, the ratio of the sine of the angle of incidence to the sine of the angle of refraction always remains constant, and the constant is known as refractive index. Remember that, students. Here, what we are using according to Snell's law, what we have, sine I, sine of the angle of incidence upon sine of the angle of refraction is the relative refractive index, mu2 by mu1. Let's say mu2 is the refractive index of the material of the prism. I'm calling it as the mu. And here it is kept in air. The first medium is air and it has the refractive index of 1. Okay, this can be further written as sine I by sine R is equal to mu. Freeze this, students. Now, here we have the two refracting angles related to the angle of prism. Here the sum of the angle of incidence and angle of emergence is equal to the sum of the angle of prism and deviation. Now listen, students. If you take this prism, you will find that the base of the prism, BC, appears to be parallel to the refracted ray, QR. Say this, they almost look parallel to each other. If the refracted ray and the base of the prism are parallel to each other, the prism is said to be at the least deviation position, students. Remember my words. If the base of the prism, this one, and the refracted ray are parallel to each other, it is said to be the prism at least deviation position. At least deviation position, students, we have a condition. There, angle I is equal to angle R. Angle I1 is equal to I2, and similarly, angle R1 is equal to angle R2. Let's say I1 is equal to I2 is equal to I, and R1 is equal to R2 is equal to R. Then is this equation, R1 plus R2 is equal to A, can be written as 2R is equal to A and R is equal to A by 2. Similarly here, I1 plus I2 is equal to A plus D and 2I. I said I1 is equal to I2 is equal to I is equal to A plus D. And I said it is the minimum deviation position. That's why I'm writing dm. That is I is equal to A plus dm by 2. Okay, students, we have angle of refraction is A by 2 and angle of incidence is equal to A plus dm by 2. Now we are substituting these two values in this relation. That is mu is equal to sine I by sine R. It is Snell's law. On substituting the values, you will get mu is equal to sine A plus dm by 2 upon sine A by 2. Okay. It is the formula to calculate the refractive index of the material of the prism, students. Okay, students, I hope you understood. Here, what you have to remember, what is the minimum deviation position is. It is very simple, students. When the refracted ray is parallel to the base of the prism, that condition is said as minimum deviation position. And what are the extracts from that? At minimum deviation position, angle of incidence becomes angle of emergence, and the angle of refraction at first refracting surface is equal to the angle of refraction at the second refracting surface. That's why we wrote these values in this such. After using the Snell's law here, we got refractive index is equal to sine A plus dm by 2 by sine A by 2. I hope you understood this. Okay, students. Once again, check the relation, students. Here we use the parallelogram and we got the sum of the angles is equal to 360 here, and as well as these are the right angles and they have the value of 90 degree each, and on substituting all we get these relations. And finally we got refractive index as sin A plus dm by 2 by sin A by 2. Now we are going to learn about the ID graph, students. That means angle of incidence versus deviation graph. Here with respect to the I, the value of the D also changes, students. It can be represented by means of a graph, students. That graph is known as the ID graph. See how it looks. Okay, students, as you learn that the refractive index can be had as mu is equal to sin A plus dm by 2 by sin A by 2. Now we are talking about the ID graph. Okay, it is a relation, already I told you, between the angle of deviation and as well as angle of incidence. Okay, we are taking angle of incidence on x-axis, students, and the deviation on y-axis. Okay, I told you these two are interrelated with each other. Here primarily at the beginning what could happen? If the deviation is very high, let's say it is the deviation, okay, it is very high, the incidence value is very less, students. Gradually what could happen? Deviation begins to decrease. On reaching a particular point, even though what's that deviation is increasing, I also increase the, students. Okay, if you plot the points differently at different deviations, I am taking few points. Okay, it is a maximum deviation, it is reduced. Okay, students, here we are getting with respect to the I here, see this. Okay, it is, see it is D1, and here we have I1, it is D2, we got it as I2, then we got a particular value D, there we have I, then after D is increasing, with respect to D, I also increase the, students. Here we got one more value. Okay, students, see, getting me, students, it's the one more value of the D. I am saying it as a D4 and it is I4. Okay, and see, we have one more is I5. I is increasing with respect to D, students. It is a D5. If you join all these lines, you will get a smooth curve, students. It seems like a parabola, students. Okay, it seems like a parabola. This curve is known as the ID graph, students. Here, this one, where D has the least value, is known as the minimum deviation function, students. Okay, and here you'll ask, what is the nature of the ID curve? It is a smooth curve, students. It is the inverted parabola. Okay, students. Here, as D increases, the I value decreases on reaching a particular point. Then, with respect to D, I also begins to increase. That's why we get a parabola. It is the ID graph, students. I hope you understood this class. Thank you for watching my video, students. If you like the video, subscribe it and please forward the video to your friends.